All right. Happy Monday. So this is Monday, 10/23, and this is an async day. So we're going to review the periodic table of elements. So first, let's take a look at the periodic table. It's broken into different classes of elements. The classes are set up as metals, nonmetals, and metalloids. So the metals are in blue here. The metalloids are in this zigzag pattern here between the metals and the nonmetals. And the nonmetals are materials that are not like metals. Metalloids share some of the properties of metals, or they're called metal-like. So let's watch this video. We'll add some questions here.
Have you ever stopped to think about how amazing your smartphone is? It has more computing power than the system NASA used to put humans on the moon. 50 years ago, no one could have imagined that you would be able to browse the web, listen to your favorite bands, and connect with your friends using a single object that fits in the palm of your hand. None of this would be possible without chemistry. About 91 of the 118 elements are metals.
And if you took a look at where those metals are, you'd see they're on the left side.
Around 20 are used to build your phone. Most metals share distinct physical properties that make them ideal for manufacturing smartphones. Metals have luster, which means they reflect light.
Another way of thinking of reflecting light is that they shine.
Smartphone designers use this property to market smartphones as a sleek and modern piece of technology. Metals form strong crystalline structures, which contributes to durability. If you accidentally dropped your phone, the metal shell wouldn't break, but you may have to live with a cracked screen. Unlike glass, metals are malleable, which means they can be hammered or pressed permanently out of shape without breaking or cracking.
So malleable, you can change the shape and they won't crack.
Your smartphone can distinguish between a tap, scroll, or zoom because of metal's ability to conduct electricity so well. Modern smartphones utilize capacitive touchscreens. The screen contains
All right, so do metals conduct electricity well? They sure do.
Contains a sheet of glass with thin lines of a highly conductive metal compound arranged in a grid pattern. At each intersection, an electrostatic field is generated and registered as neutral. When you touch the screen, a tiny bit of electrical charge enters your finger, which disrupts the field and produces a signal. Metals are ductile, meaning they can be pulled into wires.
So ductile means that you can pull them into wires.
Whenever you interact with your phone, a signal is transmitted through a complex highway of wires to your processor. Your processor is like the brain of your smartphone. Similar to the human brain, it receives signals from different parts of your phone and translates them into instructions for action. Like opening YouTube so you can watch the latest video of baby goats in pajamas. Like metals, metalloids have luster. But unlike metals, they're not malleable or ductile, so they break apart easily.
All right, the one property metalloids have in common with metals is that they have luster.
Metalloids are a crucial component of your processor because they're semiconductors, meaning they conduct electricity, but not quite as well as metals. Semiconductors allow electricity to pass through your phone's transistors in a controlled manner. If you used metal, too many of your transistors would activate, causing your processor to malfunction. The properties of nonmetals are the opposite of metals. They're brittle solids or gaseous at room temperature, and they're not malleable, conductive, or ductile.
All right, which of these properties do metals and nonmetals have in common? None of these properties are similar between metals and nonmetals.
Their specific properties are so diverse, they don't have widespread applications like metals. One application is responsible for powering up your phone. In a battery, there's a positive electrode, usually made of a lithium compound, and a negative electrode, usually made of carbon, a nonmetal. When the battery is charging, the positive electrode gives up some of its lithium ions, which move through to the negative electrode. When the battery is being used, the lithium ions travel back to the positive electrode, producing the energy needed to do things like map directions to a new restaurant in town. By utilizing the general properties of metals, metalloids, and nonmetals, we can continue to create incredible advancements in technology. Next time you
All right, which elements are used to make semiconductors? And those are
text your
metalloids.
friend about meeting up for pizza, take a moment to appreciate the complex chemistry responsible for making it happen.
All right, that's the first video. All right, so let's look at the assignment here. All right, so this is, when you do this, you're going to put these in order. Metals are typically dense, solid, ductile, malleable, and highly conductive and chemical reactive, located on the left side of the periodic table. Metalloids have properties between the metals and nonmetals and are all solids at room temperature and can act as electrical conductors under the right conditions. Nonmetals typically have 4 or more valence electrons. They are usually dull and brittle and poor conductors of heat and electricity. So this is a fill-in-the-blank assignment that you can do. All right, so here's a question for you. Elements that typically have 4 or more valence electrons, usually dull and brittle, those are your nonmetals. Elements that have properties between metals and nonmetals and are solid at room temperature and act as electrical conductors under right conditions, those are the metalloids. Elements that are typically dense, solid, ductile, malleable, ductile meaning can be stretched into wire, malleable meaning you can flatten it, highly conductive, so we know those are metals. Most of the 118 elements are located on the left side. That would be your metals. The elements that are located along the zigzag line on the periodic table are your metalloids. And the group of elements that similar characteristics in the periodic table, 3 categories are known as metals, nonmetals, and metalloids, are called your classes. All right, so we're going to talk about periods and groups here.
As you move from the light elements to the heavy elements, you keep periodically coming across the same properties, which is why it's called the periodic table. The recurring properties are organized so that you can easily see similarities between elements. The periodic table is arranged in periods and groups, going from the light elements at the top to the heavy elements at the bottom. The rows going across from left to right are periods.
The rows going across from left to right are called the periods.
Elements in the same period all share something in common. They have the same number of energy shells. Each new period row represents a new shell.
Each period on the periodic table has the same number of energy shells.
Elements in the first period have 1 shell, and as we go down, the shells increase.
So how many periods are there on the periodic table? There are 7.
Hydrogen is in the first period. It has 1 shell. Potassium is in the fourth period and has 4 energy shells, as do all the other elements in this period.
If the element is in the sixth period, how many shells does it have? It has 6.
The columns going down from top to bottom are the groups. Elements in the same group also have something in common. Elements in the same group have the same number of electrons in their outermost shell. The electrons in the outer shell are called valence electrons. This just means that these are the electrons available for reactions and bond formation. The number of
elements in the same group have the same number of valence electrons, or elements or electrons in the outer shell.
Of electrons in the outer shell governs elements' reactivity, which is why elements in the same group have similar properties.
Elements in the same group have similar properties.
The group number can tell you how many electrons are in this shell. For example, let's look at group 7. Fluorine, chlorine, iodine, bromine, and astatine. They all have 7 electrons in their outermost shell and all exhibit similar chemical characteristics. The properties show a gradual change going down the group as we go from period to period.
All elements in group 6 have 6 valence electrons and similar properties.
So, if we look at group 7 again, we can see that they are each in a different period in the periodic table, telling us that each element in this group has its outer electrons on a different shell.
So, what element is in group 7, period 3? That would be chlorine.
So, chlorine is in group 7, period 3. Therefore, it has 3 energy levels with 7 electrons in its outermost shell.
Okay. All right, so here is another fill in the blank. Periods are horizontal rows on the periodic table that contain atoms having the same number of electron energy levels. Groups and vertical columns on the periodic table that contain atoms which generally have the same number of valence electrons, giving them similar chemical properties. So let's match these. All right, found on the staircase between metals and nonmetals, that would be metalloids. The vertical columns on the periodic table would be your groups. There we go. All right. Used to organize periodic table represent the number of protons in the given element. That'd be the atomic number. The horizontal rows on a periodic table, that's your period. One or two letter abbreviation for each element. That would be your atomic symbol. Most of the elements on the periodic table are of this type. Most solids at room temperature. That would be your metals. The average mass of the element represents the number of protons and neutrons. That's your atomic mass. Okay, so period has 2 shells. So lithium has 2 shells. Period has 3 shells. Chlorine has 3 shells. Group 1, alkali metal, has 1 valence electron, and group 2 alkaline metals have 2 valence electrons. All right, so this is your last item here. This is a word wall assignment. Get started with this. What your object is to use your vocabulary. So elements that are usually dull and brittle are your nonmetals. You can get it in there. Grouping of elements with similar characteristics. Classes are typically dense metals. Oh, I missed. There we go, metals. All right, elements that are usually dull and poor conductors. Vertical columns are your groups. Where are your groups? All right, elements in periodic in the groups 3 through 12. Transition elements. All right, grouping of elements with similar characteristics. Groups, classes are typically dense. Those are the metals. Horizontal rows are your periods. Got it. Okay, grouping of elements with similar properties and characteristics. Classes. Typically dense, solids. All right, we need the metal there. All right, vertical columns are your groups. And have properties between. Oop, I missed it. There we go, metalloids. Nope, missed. There we go, metalloids. Transition metals are the groups between 13. Oop. Okay, typically dense solids. There we go. And horizontal rows are your periods. Horizontal rows are your periods. Vertical columns are your groups. Oop, too soon. There we go, groups. All right, so I'm going to stop right there, ladies and gentlemen. Enjoy your day. Rest up, but get your 5 hours in.